Today is topic, it's about initial condition. Okay, initial condition using Laplace transform. Laplace transform on differential equations. Okay, so this is what we'll be covering today, and this is the presentation that we're gonna get, okay, from the second derivative. And this one is from the first derivative. Okay, so it's just a representation, and then what we're going to do is let's find out the formula that we're going to use for this, the second derivative here. Okay, so this is we need to find this using the formula that you see here. So using that Laplace transform, we can solve for linear equation. So we may use to solve linear equation with constant. So the first thing that we need to determine the power. So in this equation, n equal to 2. This is the value, the power of n. Okay, so that's why we see n equal to 2. We're going to use that formula and find the formula. So this is what we get. Okay, n f d t n equal s n f s minus s n f minus s n we can continue. So this is what we get here. So what we're going to do, we're going to replace the value of n. Okay, in case let's try when n equal to 2. So I'm going just to write this equation. I'm going to write this equation and replace the value of n. So where is n? Okay, so n equal to 2. So I'm gonna have 2, 2, 2. Okay, so I have something like this. I'm going to continue 2. So now I'm going to write down this equation. It's gonna be 2 square f s minus s f 0 minus s to the power of 0 f 0 minus s f to the power of 0 times 0 minus f to the power of 1, okay, times 0. This will give me s square f s. We can actually see that this one is going to give me 0. This one also is going to give me 0 times something, and then so I'm gonna have negative s f of 0 minus s of f prime. Okay, so this is what we get from the second derivative. So in short, the answer when we work with the second derivative, this is what we're going to get. Okay, so we have something like this in the hand. Okay, this is the formula that we're going to use. Now let's try with the first derivative. Okay, I'm going to copy the same formula and then we're going to solve for the first derivative. Let me paste it here. And then with the first derivative, it's actually this one. Okay, so it's gonna be just similar to what we just did. Remove the power. First, we have to define the power of in this form n equal to 2. So n equal to 1. The power that we're gonna get here. Okay, since n equal to 1, so meaning this one's gonna be power of 1. So we're going to have 1, 1, 1, 1, 1, 1, 1. Okay, so this is what we're going to get here. So we're going to solve and see what we get as our answer. It's gonna be Laplace d f over dt. It will be equal to s fs minus s0 f of 0 minus s negative 1 s, okay, minus, okay, so now negative s negative 1 times 0 negative f negative 0 f of 0 times 0. Okay, this is what you're gonna get. These two going to cancel out. Okay, and here we're going to remain with this equation. It's gonna be s f s, okay, minus f o. Okay, so this is what you're gonna get. And then since we're working with the first derivative, this one in negative, we're going also to reject it. Okay, so we don't need this negative power, so we're going to reject it. So we're only gonna keep the form that you see down here. Okay, so let me just put a summary on what we just get for this steps. Okay, these are the formulas and these are what we got, and in summary this is what we got. Okay, just to give you an idea, this is in summary what we got on those two equations. And then this is for yt. So we're going to be using these formulas to solve for to convert the differential equation into S domain using Laplace. Okay, using Laplace transform. So we'll be using this formula right here. Okay, let's go and see one example where we can apply these formulas. Okay, and let me just zoom in for you to see what's it's actually happening. So and we use these formulas.